Hi, welcome to ERC TipsKnowLogy. In this video, we will be talking about assembly language programming using 8051 timers. The specific topics that I will be discussing today will be about how to calculate the initial values of 8051 timer registers, TL and TH, which is the high byte and low byte timer registers. We will also see the circuit for the 8051 timers connection, which is using LEDs, how to write the algorithm, how to draw the flowchart, how to write the assembly language program from a given problem about 8051 timers, and also a simulation example. Now, in this example, we will write the 8051 assembly language program to toggle all the bits of P1 continuously using 50 milliseconds delay in between. We will use timer 0 in the 16-bit mode to generate the delay. First of all, there are two timers that we can use, timer 0 and timer 1. As you can see here, the given in the question is timer 0. Also, we need to identify what is the mode that we will be using. Are we using mode 0, which is 13-bit, mode 1, which is 16-bit, mode 2, which is 8-bit, and mode 3, which is split mode. So it's clear here that the problem says 16-bit mode to generate the delay. Therefore, this is mode number 1. Now, to calculate the initial values of TH and TL, or low byte and high byte timer registers, we have to use the formula 2 to the power of n minus 1 minus the delay that we need divided by the quotient of 12 divided by the crystal frequency. Now, for our crystal frequency, we will be using the standard 11.0592 megahertz. And then the n will become 16 because we are using mode 1, so 16-bit timer, 2 to the 16 minus 1, that will give us 65536 minus 1, that will become 65535. And then when we look at this, the quotient of 12 divided by 11.0592 will be 1.085 microsecond. And since we cannot divide 50 millisecond by a microsecond, we will be changing 50 millisecond to 50,000 microseconds. Therefore, when we divide 50,000 by 1.085, there will be no unit, and it will be 46082 And if you subtract that from 65535, we will get 19452.0506912. And we need to round this up to make it a whole decimal number. We have to cancel the fractional part, or the decimal part here, which is 0.0506912. So rounding it up, we will get 19453. And of course, this is still given in decimal, and we have to change it into hexadecimal. And after doing so, we will get 4BFD. Take note that the TL will be TL0 because we are talking about timer 0. And the TH will become TH0 because this is about timer 0. So, and also remember to swap the values. The 4B will be the TH, and the FD will be the TL0. So in assembly language programming, it will be written in this way. We have to use MOV, or move, space, TL0, comma, space, hash, 0FDH. Now the 0 here is required whenever the hexadecimal number is a letter. So if you are using A, B, C, D, E, F for your hexadecimal number, you need to put 0 before writing the hexadecimal letters A, B, C, D, E, or F. Now, for the hexadecimal number 4B, it starts with a number 4, so no need to put 0 as a prefix before the number 4. So for TH0, we will put 4B, so this is the command, move TH0 comma, hashtag 4BH. So that's it. That's the calculation of the initial values of our timer registers TL0 and TH0. Remember that this is 0 because it's timer 0, but if it is timer 1, we need to use 1. So we will write TL1 or TH1. But because this is timer 0, we wrote TH0 and TL0. Now for the circuit, we will connect our crystal pin, crystal 1 or Xtal 1 on pin 19 and Xtal 2 on pin 18 to a crystal which is having a 11.0592 megahertz frequency. And we will have two capacitors which is equal to 30 picofarad each, which is further connected to a ground. Now we will also have reset on pin number 9, and connected to this is the resistor which is 8.2 kilo ohms and a capacitor which is 10 microfarad and a push button switch. Now the push button switch is parallel to the capacitor, and the resistor's other end is connected to the ground, while the EA on pin number 31 of our 8051 microcontroller is connected to the VCC, which is actually on pin 40, which is having 5 volts, and it's also connected to the capacitor and to the other end of the push button switch. Now, as mentioned, the port P1 will be reflecting the toggling of the different bits. So it will become 55 hexa and AA hexa, or it will be 01010101. It will become 10101010. And to show that, we need to use 8 LEDs here, which is connected to P1.0 up to P1.7. Now take note that a resistor is in series with our LED here, and the cathode of the LED is connected to the ground, and the anode is connected to the resistor, which is connected to the ports of pins of P1. Now, in this kind of circuit diagramming, we did not show anymore pin 40, which is 5 volts, positive 5 volts DC, and we did not also show the pin number 20, which is the ground. But you may do so by simply writing over here number 40, which is VCC, or number 20, which is GND. Now, for the algorithm, we will write the algorithm for the assembly language with the same start, and we have to set the origin to 0000 hex. This is the starting address of assembly language, and we always put this at the beginning of our assembly program. Then we assign 00 hexa to A. A is the accumulator, and it's assigned 00 hexa because we will give this value to port P1, and we cannot put 00 hex directly to P1. What I mean is we cannot write assign 00 hex to P1. Every time you want to put something to P1, you have to put it first or assign it first to the accumulator, which is represented by letter A. So we always do this. Assign 00 hex to A, and then we assign A to P1. But in C language, we don't need to use A. Now, the 00 hex here means that the pins of port P1 will all be used as output pins. That's why it's 00. Then on number 5, we start the main. Actually, in the assembly, we don't necessarily need to write main. We can write any other names to start our assembly language, and we put a label. We call this label with the colon. So we can write begin, colon, here, colon, or back, colon, again, colon. But just to make it similar to C, we will use main and then colon. to represent the start of our assembly language program. Now, inside the main, we will assign 55 hexa to A, and then we will assign A to P1. This is similar to saying that P1 will be equal to 55 hexa, but we cannot do it directly, so we need to put the 55 first to A, and then A will be placed to P1. And then we will call the timer delay subroutine. And after line number 8, of course, it will go to line number 13, which is to start the start of the timer delay. And we will just make it similar to C language delay that we used before, which is T0 M1 delay. But we will put colon in the assembly language later on. Now, the next is assign 01 hex to tmod. This is the same as saying tmod will be equal to 01 hexa. And then we will assign TL0 with the value of FD, and we will assign 4B hex to TH0. Remember, this is the part where we are assigning the initial values that we have calculated before, which is equal to 4B HD or 4B FD, which is 4B for the low and the FD for the high byte of the timer registers. And then we run the timer. So to run the timer, we make TR0 equals to 1 or assign 1 to TR0. And then here on line 18 and line 19, it's the same as while the timer flag of timer 0 is equal to 0, we will do nothing. That's why it's saying here we'll just jump to back. So 18 and 19 will repeat while the flag of timer 0 is 0, just like in C language. Then we will stop the timer, clear TR0, and we will clear the flag of the timer 0. So we put here clear TF0. This is the same as saying assign 0 to TR0 or TR0 equals 0, or assign 0 to TF0, or it's the same as TR0 equals 0. Take note that we always use 0 because we are talking about timer 0. And then after that, we will return to the routine that called the timer 0 delay subroutine, and that is over here on this part. So line number 8. So we will continue with line number 9. We will make A equal to AA hex, and we will make P1 equal to A. So this is the same as saying that P1 will have a value of AA hexa. And then we will call the timer delay again. And so this line number 13 up to line number 22 will be just repeated, and then it will go back to line number 12, and then from 12 it will go back to main, and the program will repeat. In other words, the P1 will become 55 hexa, and then it will become equal to AA hexa, which will be like 0101, 0101, and then it will become 1010, 1010. It's like saying that the LEDs will be like off on, off on, off on, off on. It will become on off, on off, on off, on off for the 8 LEDs. And then finally, we write end of the assembly language program. So there you go. This is how to write the algorithm of an assembly language program. Now for the next part, we will be drawing the flow chart. So the flow chart for this particular example consists of two parts. The first is the main flow chart, which is representing our main programs, program code. So we have the start, and then we assign 00 hexa to P1 to make it as an output port. And then while true, this is repeated continuously, we will make the P1 equal to 55 hexa. We will call the timer delay. So the timer delay flow chart will run. This is like saying that the tmod will be equal to timer 1 mode, timer 0 mode 1, and then the TLO will be equal to FD, and the THO will be equal to 4B. Actually, there's a mistake here. The TL0 must be equal to 4B for our THO, and the TLO must be equal to FDH, not 00H. maybe because this came from another flowchart that we did before. So again, correction, TL0 is equal to FDH and TH0 will be equal to 4BH. Then we run the timer equal to 1, and then while the timer flag, not F0, actually this is TF0, while the TF0, correction again, so this is while the TF0 is equal to 0, we will do nothing, and then we will stop the timer, and then we will make the flag of the timer equal to 0 or reset. So this is the flow chart of our example, but take note of the correction. TL0 equals FDH, TH0 equals 4BH, while TF0 equals 0, not F0. So the T is missing over here. Now for the program, we will be writing the program in assembly in this way. First, we need to write origin, org, or org, 0000H, and then we have to move to A the value of 00H. Now you will notice that we write first the target or the destination before the value that we are supposed to put to A, and then we will put or move the value of A to P1 in this way. And then this is what I'm saying about the main program. We will make a label main and then colon, and then from number 5 up to number 11 will be what's inside the main. So we will make the A55H, and then we will make P1 equal to A. It's the same as P1 will be equal to 55 hexa. And then we will call the timer delay. Never mind the A here, it means absolute call. You can write call, you can also write A call. And so we write A call T01 M1 delay. So the label here, which is T01 M1 delay, will be running, and it will make T mod equal to 01 hexa. TL0 will be FDH. TH0 will be 4BH. Take note of the 0 before the letter F. Again, we put 0 because in the assembly, we need to write 0 before the hexadecimal number A, B, C, D, E, F. But if it is a number, like the case of 4, we don't need to do so. We don't need to write 0 there. And then here, set B TR0 is the same as TR0 will be equal to 1. So in assembly, we use set B to make TR0 equal to 1. Then we go ahead with the back here, and this back colon will be repeated while the flag is equal to 0. So line number 17 and 18 will just be repeated while the flag of timer 0 is equal to 0. And then after that, we will stop the timer, CLR TR0. We use CLR to make the TR0 equal to 0. So it's the same as TR0 equals 0. CLR or clear the timer flag of timer flag 0, and then ret means return. So we will return to the calling instruction, which is over here. So we will be calling, we called it from line 7. So we go to line number 8 now, which is to put AA hexa to A. You will notice again it starts with A, so we put 0, and then we put A to P1. So in other words, P1 will be 55, and then P1 will be AA. So AA means 10 in decimal, which is actually 10101010 in binary. In other words, our P1 will become 0101, 0101, and then it will be toggling, it will toggle to 1010, 1010. And then there will be again a delay. So we call here the delay T0M1 delay, and so it will go again to line number 12, and it will execute up to line number 13, 14, 15, and 16, which is giving us, if you will remember, we calculated it, it's only giving us a delay of 50 milliseconds delay. And that's it. And then finally, we have to go back to main. So SJMP means short jump in assembly, although you can also write JMP if you want. So SJMP it will go to main, and it will repeat the process again and again, or repeatedly or continuously. So there you go. This is the assembly language program for our problem. Now, in the next part, this is the simulation using the EdSim simulator. So if you do this by EdSim, what will happen is that there will be an LED on this part. If you will notice there, this is colored white, red, white, orange, white, green, and white, red. So the white is off, while the one with colored LEDs is on. So in the beginning, port P1, which has 8 LEDs, will be like off, on, off, on, off, on, off, on, which is the value of 0101, 0101, or 55H. But if this LED is active high, it will do the opposite. And this is our assembly program that we wrote here. So this part, this is the assembly program that we discussed. And when you run this, this will turn on, will toggle between this value and this value. So in the second the picture that you will see here, the LEDs are now like this: on, off, on, off, on, off, on, off. You see the orange, white, green, white, red, white, orange, white. The white means off. So port P1, which has 8 LEDs, will now be the opposite, which is on, off, on, off, on, off, on, off, which is also 1010, 1010, or in hexa, that is AA. And this is our assembly language program here in the middle. So there you go. This is the simulator used by using Ed Simulator. And if you want to use another simulator, there's one more simulator. We call it Proteus or Proteus. And for Proteus, we will see that this is actually the circuit that I used also to draw the circuit. And you will notice here at the bottom that the LEDs are off, on, off, on, off, on, off, on. But after 50 milliseconds, it will become on, off, on, off, on, off, on, off. So there you go. This is the example of the assembly language program. And we have completed our lesson about how to calculate the initial values of our timer registers, TH and TL. We learned how to draw or to prepare the circuit for the problem. And then we learned how to write the algorithm. We also learned how to draw the flowchart, and also how to write the assembly language program for the timers. And finally, I showed you one example of simulation, or actually two, one using Ed Simulator and the other one is using the Proteus Simulator. You can also do this by the multisim that I have shown in the previous videos. Thank you so much for watching, listening, and learning with us. And I hope that you will subscribe, like, and share this YouTube channel in order to support us towards our goal of having 1,000 subscribers at least. So please help us, and let us help also other beginners in assembly language programming who wants to make a project or a program in 8051 microcontroller, or later on maybe in Arduino. So if you will watch our other videos. Thank you so much and have a nice day.